The golden telescope we humans built is currently taking some mind-blowing pictures of space. It's so powerful that it might have just shattered our understanding of the universe. Betelgeuse, the massive red supergiant star located in the Orion constellation, has long captivated astronomers and stargazers alike. In recent years, this cosmic giant has been the subject of intense scrutiny, especially after an unprecedented dimming event in late 2019 and early 2020. However, in a stunning turn of events, the James Webb Space Telescope, JWST, has recently detected an extraordinary 1,000% increase in Betelgeuse's brightness, sending waves of excitement and intrigue throughout the scientific community. This sudden surge in brightness has left astronomers both puzzled and eager to understand the underlying causes. Betelgeuse, one of the largest stars visible to the naked eye, is nearing the end of its life cycle, a phase that makes it prone to dramatic changes in brightness and behavior. The unexpected brightening is one of the most significant and unusual phenomena observed in the star's recent history, defying current models and theories that have long governed our understanding of stellar evolution. Betelgeuse's size and proximity to Earth make it one of the most studied stars in the night sky. As a red supergiant, it is many times more massive than our Sun and considerably older, and it is expected to explode in a supernova when it eventually exhausts its fuel. However, the precise timing of this explosion remains a mystery. The recent increase in brightness has heightened speculation about what might be happening deep within the star. The sudden brightening detected by the JWST is surprising for several reasons. While Betelgeuse's brightness has fluctuated in the past, these changes were gradual and followed predictable patterns tied to the star's pulsations. Red supergiants like Betelgeuse undergo cycles of expansion and contraction, naturally causing their brightness to vary over time. However, a 1,000% increase in brightness is far beyond the typical fluctuations expected from these pulsations, suggesting that something far more dramatic is occurring within the star's core or its outer layers. One possible explanation for this event is that Betelgeuse may be entering a new, more unstable phase of its life. As stars of this size age, their outer layers can become increasingly unstable, leading to sudden and massive outbursts of energy. These outbursts, sometimes referred to as shell ejections, occur when the star expels significant portions of its outer material into space. If Betelgeuse has experienced a shell ejection of this magnitude, it could account for the dramatic increase in brightness observed by the JWST. Another potential cause could be related to changes in Betelgeuse's core. As red supergiants approach the end of their lives, the fusion processes at their core begin to shift. Betelgeuse is believed to be fusing heavier elements such as oxygen and silicon in preparation for its eventual supernova. Changes in these fusion processes can trigger violent and unpredictable behavior in the star's outer layers, and the recent brightening could be a sign that Betelgeuse is entering the final stages of its life. While this doesn't necessarily mean a supernova is imminent, it does suggest that significant changes are underway. Despite the excitement surrounding this event, it is important to note that Betelgeuse's behavior has been enigmatic before. The star's famous dimming event in 2019 caused widespread speculation that it might be on the verge of a supernova. However, subsequent observations revealed that the dimming was caused by a large cloud of dust injected by the star, temporarily obscuring its light from Earth. This recent brightening could be similarly misleading, possibly caused by another dust-related phenomenon or some other external factor. Yet, the sheer magnitude of the brightness increase detected by the JWST suggests that this is more than just a passing event. If Betelgeuse is indeed on the cusp of a major change, it could offer scientists an unprecedented opportunity to study a red supergiant in the throes of its final stages. While we have observed supernovae in distant galaxies, Betelgeuse is close enough that any such event would be visible in extraordinary detail. This proximity means that if Betelgeuse were to explode, we would be able to observe the process in real time, capturing data that could significantly enhance our understanding of stellar evolution and supernova mechanics. The implications of Betelgeuse's sudden brightening extend beyond the star itself. A supernova within our galaxy would have far-reaching effects on the surrounding region of space. Fortunately, at a distance of approximately 640 light-years from Earth, Betelgeuse is far enough away that any potential supernova would not pose a direct threat to our planet. However, the explosion would still be an awe-inspiring and potentially transformative event. For weeks or even months, Betelgeuse could become visible in the daytime sky, rivaling the brightness of the moon. The event would provide astronomers with a wealth of data on the aftermath of a supernova, including the formation of neutron stars or even black holes. In the immediate aftermath of this brightness surge, astronomers are scrambling to gather as much data as possible. Observatories around the world, both ground-based and space-based, are turning their attention to Betelgeuse, hoping to capture every nuance of this unfolding drama. The JWST, with its unparalleled ability to observe in infrared wavelengths, is particularly well suited to study Betelgeuse's outer layers and the material it may be ejecting into space. The telescope's observations could reveal whether this increase in brightness is due to a significant change in the star's structure or if it is the result of an external factor, such as dust or gas clouds interacting with Betelgeuse's light. This sudden brightening has also sparked renewed interest in studying other red supergiants. While Betelgeuse is one of the closest and most prominent examples, there are many other stars in the Milky Way that are in a similar stage of their life cycle. If Betelgeuse's behavior is indicative of a previously unknown phase of red supergiant evolution, it could lead to a broader re-evaluation of our understanding of how these stars behave as they approach the end of their lives. This, in turn, could improve our ability to predict supernova events, potentially offering more precise timelines for when other nearby stars might undergo similar transformations. The increase in Betelgeuse's brightness also underscores the importance of the JWST and other advanced observatories in the field of astronomy. The JWST's ability to observe the universe in unprecedented detail is providing scientists with new insights into phenomena that were previously difficult or impossible to study. In the case of Betelgeuse, the telescope's observations are offering a front-row seat to one of the most dramatic events in the life of a star, a process that could unfold over years or even decades. These observations are not only deepening our understanding of Betelgeuse but are also opening new windows into the broader processes that govern the life and death of stars. The mystery surrounding Betelgeuse's sudden increase in brightness is a reminder of the dynamic and often unpredictable nature of the universe. While scientists have made tremendous strides in understanding the life cycles of stars, much remains unknown. Events like this serve as a powerful reminder that our models and theories, while sophisticated, are still evolving. Each new observation offers the potential to revise or expand our understanding, and the sudden brightening of Betelgeuse is a perfect example of how unexpected phenomena can challenge long-held assumptions. As the investigation into Betelgeuse's sudden and unprecedented 1000% increase in brightness unfolds, scientists are diving into a variety of hypotheses to explain the anomaly. The red supergiant's erratic behavior has rekindled curiosity about stellar processes that remain shrouded in mystery, particularly in the late stages of a star's evolution. Although Betelgeuse is known for its unpredictable fluctuations in brightness due to its pulsating nature, this recent surge is far outside the typical range of variation observed in its life cycle. Now, with the James Webb Space Telescope delivering high-resolution data, the astronomy community is racing to understand what might be triggering such an extreme event in this aging behemoth of the cosmos. The JWST's role in this investigation cannot be overstated. As the most advanced space observatory currently in operation, the JWST offers unprecedented access to Betelgeuse's outer layers, which can provide crucial insights into the forces at work inside the star. By capturing infrared wavelengths, the JWST can peer through dust clouds and atmospheric particles that might have obscured earlier observations, allowing astronomers to study the star's surface and atmosphere with unparalleled precision. This capability is essential to unraveling the cause of Betelgeuse's current state of heightened luminosity, and every new dataset provides fresh leads in the ongoing investigation. One of the most exciting prospects that scientists are exploring is the possibility that Betelgeuse's dramatic increase in brightness could be linked to an internal phenomenon that has, until now, eluded observation. Betelgeuse is known to fuse progressively heavier elements as it approaches the end of its life, working its way from hydrogen to helium, and eventually to elements like oxygen, silicon, and iron. This fusion process results in extreme pressure fluctuations inside the star, manifesting as surface instability, violent mass ejections, or even catastrophic events like supernovae. The sudden brightness spike detected by the JWST could indicate that Betelgeuse has entered a volatile phase of its evolution, where core dynamics drive unpredictable changes at the star's surface. As the red supergiant nears the end of its stellar life, one of the most important processes occurring within Betelgeuse is the fusion of increasingly heavier elements. Scientists have long hypothesized that as a star of this size fuses elements like oxygen and silicon, it creates a complex and delicate equilibrium between gravitational forces pulling inward and radiation pressure pushing outward. When this equilibrium is disrupted, it can lead to a phenomenon known as core collapse, where the star's core suddenly collapses under its own weight, followed by an immense release of energy. This is the trigger for a supernova explosion. While there is no certainty that Betelgeuse's recent brightening signifies an imminent supernova, it raises the possibility that the star is undergoing intense internal changes that could culminate in such an event in the near future. In addition to core fusion processes, the surface of Betelgeuse is also an active area of study. Red supergiants are known for having highly dynamic and unstable surfaces due to convection cells that dominate their outer layers. These cells are vast bubbles of plasma that rise and fall as heat from the core is transported to the surface. Betelgeuse's massive size, with a radius estimated to be around 700 times that of the Sun, means that these convection cells are far larger and more turbulent than those found in smaller stars. Recent studies using JWST's advanced instruments have indicated that Betelgeuse's surface could be experiencing increased convective activity, leading to larger, more violent upwellings of material. This may have caused the star to temporarily increase its brightness as more hot plasma is exposed at the surface. Moreover, another potential factor contributing to the sudden increase in brightness could be a large-scale mass ejection from Betelgeuse's outer layers. Red supergiants are known to shed massive amounts of material as they age, and these ejections can form large clouds of dust and gas that surround the star. Such material can either obscure the star's light or, in some cases, reflect and amplify it, depending on the surrounding environment. If Betelgeuse recently ejected a particularly dense shell of gas, it's possible that this material could be interacting with light from the star in a way that amplifies its brightness as seen from Earth. Alternatively, a previous ejection could have cleared away some of the surrounding dust, allowing more of Betelgeuse's intrinsic brightness to reach observers. The exact mechanics of these mass ejections are still being studied, but they represent another possible explanation for the brightness increase observed by the JWST. While much of the focus has been on internal processes, Betelgeuse's environment in the Orion constellation may also hold some clues. The star resides in a complex region of space filled with interstellar gas and dust, which can influence how its light reaches Earth. Changes in this surrounding material, such as shock waves or ionization fronts caused by Betelgeuse's own outbursts, could interact with the star's radiation in unexpected ways. Scientists are also exploring the possibility that a nearby object, like an unseen companion star or a passing celestial body, could be affecting Betelgeuse's light output. Though this scenario is considered less likely than internal mechanisms, the JWST's ability to map the star's surroundings in fine detail could help rule out or confirm such external influences. As the excitement surrounding Betelgeuse's latest outburst continues to grow, the broader scientific community is looking at the potential consequences of such a massive change in the star's behavior. If the brightness increase is indeed a precursor to a supernova, it would mark one of the most significant astronomical events in human history. A supernova explosion from Betelgeuse would not only be a spectacular sight, potentially visible even during daylight hours, but also offer a once-in-a-lifetime opportunity to study the mechanics of a nearby supernova in real time. Currently, supernovae are often observed in distant galaxies, making it difficult for astronomers to gather detailed data about their progression. Betelgeuse's proximity to Earth, at around 640 light-years, would provide scientists with an unprecedented vantage point to observe the complete life cycle of a supernova event, from the initial collapse to the eventual formation of a neutron star or black hole. This data could revolutionize our understanding of how stars die and shed light on the processes that create some of the universe's most extreme objects. Furthermore, a supernova in the Milky Way would have significant implications for the study of cosmic rays and the broader galactic environment. Supernovae are among the most powerful sources of cosmic rays, high-energy particles that travel through space at nearly the speed of light. These particles can interact with other matter and magnetic fields in space, contributing to a wide array of astrophysical phenomena. A supernova as close as Betelgeuse would provide scientists with a unique opportunity to study the generation and propagation of cosmic rays in detail. This, in turn, could lead to new insights into the role that supernovae play in shaping the interstellar medium and influencing the evolution of galaxies. While the potential scientific benefits of observing a supernova up close are immense, there are also more practical concerns about the effect such an event could have on our solar system. Thankfully, Betelgeuse is far enough away that its explosion would not pose any direct danger to life on Earth. However, the intense radiation and high-energy particles produced by the supernova could have subtle but measurable effects on the space environment around our planet. Satellites, spacecraft, and other space-based infrastructure might be exposed to increased levels of radiation, which could affect their operation. Additionally, the sudden influx of energy into the solar system could influence the behavior of the solar wind and Earth's magnetosphere, though these effects would likely be temporary and relatively minor. Beyond the immediate scientific implications, Betelgeuse's sudden brightening also offers an opportunity to engage the public with one of the most captivating aspects of astronomy, the dynamic, ever-changing nature of the universe. As one of the brightest and most recognizable stars in the night sky, Betelgeuse has long held a special place in human culture and mythology. Its prominence in the Orion constellation makes it a familiar sight to stargazers around the world, and any significant change in its appearance would likely capture widespread attention. If Betelgeuse were to undergo a supernova, it would be an awe-inspiring event, visible to the naked eye, likely drawing millions of people to look up at the sky and wonder. In this sense, Betelgeuse's behavior serves as a powerful reminder of the connections between astronomy and human experience. For thousands of years, people have looked to the stars for guidance, inspiration, and a sense of wonder about the universe. The study of stars like Betelgeuse helps us understand not only the physical processes that govern the cosmos but also our place within it. Events like the recent brightening detected by the JWST remind us that the universe is an active and dynamic place, full of surprises and mysteries waiting to be uncovered. At the same time, this event underscores the importance of continued investment in astronomical research and technology. Without the JWST, this dramatic increase in Betelgeuse's brightness might have gone undetected or been misinterpreted due to the limitations of previous observational tools. The telescope's ability to capture detail across a range of wavelengths has proven essential to piecing together the puzzle of what is happening inside Betelgeuse. As astronomers continue to analyze the data coming from the JWST and other observatories, the star's sudden brightening may lead to new discoveries, not only about Betelgeuse itself but about the broader processes that govern the life and death of stars across the universe. As the astronomical community grapples with the implications of Betelgeuse's unprecedented 1,000% increase in brightness, new dimensions of inquiry are beginning to emerge. While much of the focus has been on internal stellar processes and the potential for a forthcoming supernova, numerous other angles are being explored. These avenues span from the fundamental principles of astrophysics to the broader context of how this event fits into our understanding of galactic dynamics and stellar behavior across the universe. With Betelgeuse now at the center of one of the most watched and discussed celestial phenomena in recent memory, it opens the door to rethinking not only the life cycles of stars but also the tools and methodologies used to study such dramatic cosmic events. One of the most intriguing aspects of this brightness increase is how it intersects with theories of stellar magnetic fields. While magnetic fields in stars like our Sun have been studied extensively, the behavior of magnetic fields in massive stars like Betelgeuse is less understood. As a red supergiant, Betelgeuse may possess a highly complex magnetic field structure, possibly contributing to the recent outburst of energy. Massive stars are believed to generate strong magnetic fields through their convective layers, where material churns and circulates, creating electric currents. These fields can undergo significant changes during a star's life, especially as it approaches its final stages. One hypothesis is that Betelgeuse's magnetic field may be playing a pivotal role in this sudden increase in brightness. A dramatic rearrangement or intensification of the star's magnetic field could lead to large-scale disturbances in its outer layers. These disturbances might manifest as energy flares, surface hotspots, or shifts in the star's overall brightness. The interaction between magnetic fields and the convective processes in the outer layers of a red supergiant is a burgeoning field of study, and Betelgeuse's recent behavior could provide a rare opportunity to observe such phenomena in action. If a correlation between the star's magnetic activity and its brightness changes can be established, it may open up a new dimension of understanding for how magnetic fields influence stellar evolution and the transition to supernova. Another area of interest is how Betelgeuse's potential supernova event might influence its surroundings. When a star as massive as Betelgeuse explodes, it releases an enormous amount of energy into space. This energy has a profound effect on the star's immediate environment, sweeping up surrounding gas and dust and creating shock waves that propagate through the interstellar medium.